Hello class. This week we're going to switch gears a little bit. We're going to get away from web programming for a couple of weeks, and we're going to switch into JavaScript. So we've focused mostly on HTML, which sets up the content of the page, and CSS, which sets up the styling of the page. Now we're going to start looking at JavaScript, which adds interactivity and logic and animations and all sorts of other good stuff that can only be done by a programming language. But before we get into how it works on a web page, we need to spend a little time understanding the JavaScript language itself. So if we look at week 6, we're going to start by looking at an introduction to JavaScript. Then we're going to start looking at the syntax and variables and conditionals and loops and variables and functions and arrays, all sorts of topics and items that we should have seen in prior programming classes, such as CST 112 or perhaps CST 141. I do believe CST 112 is a prerequisite for this class. So keep in mind that as we go through this section, if these things look extremely foreign and unfamiliar to you, please reach out to me so we can have a discussion and get you back up to speed on it. We also have in our test area, we have the HTML sandbox, we have a CSS sandbox, and now we have a JavaScript sandbox, which I have opened in another tab, and I'll be jumping over to there periodically to do some coding examples so you can see how it works. So first of all, what is JavaScript? Well, JavaScript is the language that allows us to add interactivity to web pages, such as error checking, form submissions. Have you ever seen when you go to enter a password and it says not enough digits or not enough special characters? Well, that's JavaScript. Have you ever tried to go to a web page and a big pop-up appears and says you have to subscribe before you can read this content? Well, that's also JavaScript. So JavaScript adds a lot of functionality to web pages that we can't normally do with HTML and CSS. Originally, it was designed to run in browsers, and only in browsers. But since then, it's migrated out and now can be run on servers directly. So you can actually write entire programs in JavaScript that don't run in the browser at all. So it is a pretty powerful language, and it's always evolving. As we start looking at the JavaScript syntax, you'll notice it's very, very similar to Java itself. So a little history. Java was created in 1996 by a company called Sun Microsystems. Today, Oracle owns the rights to Java. It was purchased from Sun Microsystems. JavaScript got its start as a product called Mocha, and then it was eventually renamed to LiveScript. And that was released in 1995 to be used in the Netscape Navigator browser, one of the first internet web browsers. The term JavaScript itself emerged from a marketing agreement between Netscape and Sun Microsystems. Netscape renamed LiveScript to JavaScript to capitalize on the popularity of Java at the time. Java was a very popular programming language when it was first released. So this was a strategic move between the two companies to foster a wider adoption of JavaScript as a programming language that would be great for web programming. And you could see the syntax is very, very similar between the two. While they do look the same on the surface, behind the scenes they are very, very different. Java is compiled, it is object-oriented, and it is used for large applications. JavaScript is an interpreted language and is predominantly used for front-end web development. There are back-end developments for JavaScript, that use something called Node.js or other servers to be able to run JavaScript on its own on the back-end servers to interface directly with databases. And we'll look into more of what front-end versus back-end development looks like in another video. So as we could see here, JavaScript adds interactivity to web pages. It's going to run in our browsers, so every browser that we have, Chrome or Microsoft Edge or Opera or any of the others, are responsible for interpreting the JavaScript code that is downloaded from the web page. And it runs in the browser itself, so you don't need to install anything special for JavaScript. It comes directly with whatever browser you're using. And some of the common uses are forms, animations, and DOM manipulation. Now, DOM is a whole other subject that we'll get into in another video, but that is one of the models that allows JavaScript to take over and control all elements of HTML and CSS and gives you that full functionality and interactivity that we need. Okay, so at a high level, let's start looking at JavaScript. JavaScript is a case-sensitive language, so variable names need to be spelled properly. You can't have two variables used the same way with different spelling. So you can't have an uppercase and a lowercase spelling of the same name be used in the same place. It will be two different variables, and we'll see an example of that as we write some code. Statements end with semicolons, similar to Java. And you have your comments are the two slashes or the /*/ methods, also similar to Java. Variables are declared with a let statement, and you notice you don't need to include a data type. So we don't need to worry about that. That's similar to Python. We don't need to worry about putting in any integers or ints or floats or doubles or strings or any of that. We just need to give it a let to tell it we're going to let this variable equal a value. Now there's also a const identifier where we can set up a constant value. So you could see that let, in this particular example, let name equals ed in single quotes indicates a string. Strings can be separated by either single quotes or double quotes. It's flexible that way. Constant pi, C-O-N-S-T, pi, equals 3.14. So that declares the variable pi, assigns it to the value of 3.14, but you cannot change that value again. Now, var is interesting. Var is an older implementation of declaring a variable, and it's not recommended to be used any longer. Use let. You'll get much better performance. var has an interesting property where you can actually use a variable before it's declared. And maybe I'll start showing some examples of how this all looks now. So let's jump over to our test window. And here we have some basic code. You'll notice that the console.log is what allows us to display a message to the log screen below, the console screen below. This is similar into Java, into the system.out.println statement, which we've probably seen in the past in CST 112. So let me just delete this. We're not going to use that. And let us take a look at that initial code that we have here. Copy that, paste it over here, clean it up a little bit. And you can see we can print these statements. Name equals plus name, and we can run it. And there it goes, it printed my name. If we wanted to, let's say we wanted to change the value of pi, and we wanted to set pi equal to a different value, we could try to do that with an assignment. But first, let's print it, console.log, pi equals plus pi. And we'll run it. Pi is equal to 3.14. Let's say we change our mind and we want to make pi a little more precise. Pi equals 3.1415. 92 something. Okay. And then we want to print it again. And we run it. you notice we get an error. And the error tells us right here, similar to a Java stack trace, it tells us that we cannot do an assignment to a constant variable. Here's our error. So once a constant is declared, it's declared, and it cannot be changed. So I will delete this since we do not need it any longer. Now var. Var is an interesting variable in that, or a type of syntax for declaring a variable that has an interesting property called hoisting. Hoisting is the ability to use a variable before it's declared, but the value will be undeclared. So let's do an example. Console.log, and I'll need a variable, my variable. So if I run this, I did not declare variable anywhere, or my variable anywhere. It does not exist. So if I run it, oh, I'm getting an error. Why am I getting an error? The other way of assigning a variable and creating a variable is the var syntax. Var is not recommended to be used any longer. You should be using let and const. Var has a weird property that allows you to access a variable before it's been declared, and what will happen is the declaration will be hoisted to the top of the block where the code is valid and be inserted there for you. So not a good way to do coding, so we're not going to use var. We're just going to stick with let, and I am going to delete our var reference once and for all, and that will be the last time we see that. It just is a very confusing thing and could cause problems. The let construct functions much more like normal, or what we call normal data declaration that we see in languages like Java, so we'll just stick with that. We can also assign other values to let using let or a variable. So let's change the name of the name variable. We'll set name equal to, I don't know, Joe. And I don't understand why it's underscoring name like that. Name is deprecated. Name must have been a keyword at one point and it's no longer used. So we should be careful, make sure we don't use variable names that are or were keywords. It could cause issues. So I'm going to change name to first name. I'll change first name here. And I'll change it to first name here. Just to get everything back on the up and up. And if I go to print first name again, I would now expect it to see Joe the second time, and it does. We can also do something like this. We could set first name equal to a number. Now, Java will complain about this. It definitely does not like that. But if I go to print the console here and run it, it'll say first name equals 55. So I can change the data type from a string to a integer just by assigning it an integer value. I don't need to do any casting or any changing or anything. So you need to be careful and make sure you know what your data holds and what's in it at any time in case you want to do some math operations or something else. So you can assign numbers and strings to the same variable, and it will happily keep track of that for you. Okay, so let's go take a look and see what kind of data types are available for us. Well, we're going to start out with the primitive types. We're going to start out with strings and numbers. We're going to start out with a Boolean, which is the true-false. We're going to start out with an undefined, which is, well, undefined. Null is a null value. A symbol and a big int, big integer. Later, we'll take a look at objects, arrays, and functions. And those are the types we're going to be looking at. So we're looking at primitive types, and we're looking at reference types. And here's a whole bunch of examples how we can assign values. Here's this str equals hello, a number is equal to 42. A Boolean is true equals to the value of true, or you could use false. We're creating an object, and we'll talk about objects later, and we're going to talk about arrays. And this should look familiar to CST 112 students. So, like I said, JavaScript is dynamically typed, meaning a variable can change its types at runtime. There is an operator we can put in front of the variable name to get the type of variable that it is, called typeof, to check its variable type. So you can use this when you want to do something about combining strings, and if you're not sure if one's a string. So you could use typeof, and I'll show you a quick example of that. If we do typeof here, I would expect it to say string. And if I do typeof down here, I would expect it to say int. So let's see if that is what happens, and it is. So the type of first name here is a string, and the type of first name here is an int. Okay, good. Next, we'll take a look at some math operators. And the standard ones apply: plus, minus, multiply, divide, modulo, and exponentation. And you can do your typical math operations: a plus b, a modulo b, a raised to the power of b. So those are pretty straightforward. Do a quick example. Let's create another variable. We'll call it let r1 equals 10, let r2 equals 20. I'm going to comment out this other stuff for now, only because it's getting in the way. And we can do var3 equals, oops, forgot to let. var3 equals var1 times var2, and we can do console.log var3, and we should expect it to print out the value of 200, and it did. So you can do your math, you can do plus and run it, you can do modulo. Let's see what 10 modulo 20 should give us a 0, or it gives us a 10. The 10 is remainder, sorry. We can do exponents with the two asterisks. And 10 raised to the power of 20, it's 10 with a whole bunch of zeros after it. So we can do all our standard math kind of operations. We also have the ability to do conditionals. So we can do our decision making. And the syntax is very, very similar to Java. It's got the if with the condition in parentheses followed by the code block. And the code block is what allows us to separate pieces of code or segments of code so they can be executed properly. In this particular example here, why don't we just copy it and we'll actually put it in here. And I'm just going to replace this because we don't need that. But here is our if statement. And if we say let score equals 95, and then it will run through here. If score is greater than 95, it will print an A. Otherwise, it'll check to see if it's greater than 80. It'll print a B. Otherwise, it'll print a C. My program produced no output because I forgot to print the actual grade. Now, has anybody seen any issues with this? Am I declaring the variable grade anywhere? I am not. But it knows that I have a grade and it's going to create it for me. So you can almost argue that that let really isn't necessary, but try to use it. It'll make your life much easier. And if we change this to 85, it'll print a B. Oops, not 55. That'd be impressive. But there's your 85, it'll print a B. So here's your if statement. Again, similar to what we've seen before. Next, we have our logical operations, logical operators, and or not. It's a way of combining multiple Boolean expressions together with either the and or the or, and not would be the one that would be done on its own. Just again, a note, and returns true only if both conditions are true, or returns true if only at least one is true. And the exclamation point will negate a condition. And make sure you use parentheses if you want to have things executed in its very specific order, or if you have very complex calculations. We have loops. Loops are the same basic format again as Java. You have your for loop, you have your while loop, you have your do while loop. For loops again, good for fixed iterations. While loops are good for unknowns, and do while is guarantees that the loop will execute at least once. You need to make sure your loop variable is updated to make sure the loop does not run infinitely, which is very bad for browsers. It will never finish loading the page and eventually time out and fail. And then there's some other fancier loops, for of and for each. And we'll take a look at for of in a minute, because that's an interesting one that's used with arrays. So if we take we'll take an example here of a while loop, and we'll put our while loop in here, and we'll put it after the grade. If we set the count equal to 0, and we loop from 0 to 5, we're going to see an output of count plus plus. So there's our syntax of count plus plus, again, similar to Java. In a loop, 0 to 4 exits when it gets to 5. Very simple loop syntax. Now, I should also note that when we do our web page development, we're not going to be doing very, very complex calculations similar to what we would do in a Java class. These are just some basic examples to demonstrate how the Java code or JavaScript code works. We also have functions, so we can create our reusable code blocks inside of JavaScript. So we can have our own custom functions, so we don't have to write the same code over and over again. Now, I'm going to delete this line here because we are not going to talk about that particular line. But I did want to show you this example. So here's a function, and we're going to pop it over into our test window here. And the function's name is greet, and it's taking a variable as a parameter, name, and what we are going to return is the value of hello name. Hello name. And I'm going to delete this and change it up just a little bit, just to get it to the syntax that we're used to. So there it is. I'll make sure I have the right number of quotes, and I do. And I'm going to take this code and put it back into our slide deck. Have it a little bit different. Merge formatting. There we go. So if I run this, I don't see any difference. I see the same output. I see my letter grade. I see my loop counting, but I don't see my function. Well, that was just the declaration of the function. We now actually have to call the function, and we can do something along the lines of where I use the function name and I give it its argument, so it can take this argument, pass it up to the function, do the function's logic, and then print the result. So the result is returned to the calling function, and it is then displayed on the console. And there it is. So, very simplistic example, but it shows you how you can create reusable code that you can use in multiple places. Now, a function does not need to return a value. It can just do a series of tasks, and that could be useful, but in general, they do return values from a function. Okay, so back to our notes. We're going to take a look at a couple more things, and then we'll wrap it up for today. We're going to look at arrays. So arrays allow us to have a collection of data, or a list of data, and we can define our arrays kind of like this. Here's our list. In this example, we're going to use fruits. So we have a list of fruits. We have apples, bananas, and cherries. And we can do our indexing similar to how we do indexing in Java. It starts at 0 and use the square bracket notation to pick out the element in the array that you want to access. Starts at 0. And the interesting thing about this is we can store mixed data types. Java cannot do that. Python can. And JavaScript can. So we can have an array of mixed data types. But usually it is the same data type throughout. And there are some interesting methods that go along with arrays. You could push, where you could put something new on the end of the array. Pop, you could pop something off the beginning of the array. You could shift, you can unshift, you could splice it and make different pieces out of it, and you can get its length as a property. So there are different actions you could do. Let's take a look at some examples and put it into our code and try it out. And you'll see that in the first example, if I run it, I will get banana. Why is it not running? There it goes. Okay. If I had put in another value, let's put in a number, and I run it. Well, it still gives me banana because I didn't change the index. So we have 0, 1, 2, 3 will be our last one, and it printed out the value of 10. So now you have an array of mixed data types. So you can certainly put things on a list, and you can use a list to contain anything you want. So another interesting property is you can add things to our list. And I'll demonstrate that now. We can do fruits dot push, and we could put something else on there. Why don't we put our buddy pie on there and see if that will go. We'll run it. It did. Oh, we got to print it. Console.log.fruits 4. 4 should be at the end now because we just pushed a new element onto the list. And I would expect to see that have our new value of pie. So now we have, I can't believe I'm going to say this. Now we have fruit pie. Sorry, I had to say it. So you can see how you can push different values into the list. Okay, I'll wrap it up with one more slide after that really bad joke. This is a different kind of loop. This is called a for of loop. Other languages may call them a for each loop. It essentially allows you to iterate through a loop and use one variable to reference each item in your list without needing to give it an index. So this is your syntax. I'm going to take this out of here, and we're going to put it over here at the bottom of our list. And for n in, not nums, but we're going to use fruits. And I am simply going to just write down each item. So you see I am going to loop through this entire array, or this entire list. I am going to interrogate each element with the variable n, and I'm going to print it. So I'm not going to use any indexing. I'm not going to use any elements. I'm just going to print the values in the list. And here they are: apple, banana, cherry, 10, and 3.14. So it's a handy little loop when you want to treat each item and deal with it individually, and you don't have to worry about using any indexes or elements. It makes your code a little easier to read too, I think. Okay, so that's all I really wanted to talk about at this point. Next week we'll get into a little more advanced JavaScript, and then we'll see how we can work JavaScript into our DOM and actually modify HTML elements and CSS styling and all sorts of stuff. So your labs are, you have 3 labs, and you'll notice they are more programming labs. I'll just pop into one real quick here. They're more programming style labs than web development labs. So brush off those cobwebs for programming and give these a try. And next week we'll get back into starting to look into how we can use JavaScript to modify HTML and CSS. Okay, that's it for tonight. Good luck, and I'll see you in the next one.